Hey guys, let's go ahead and read lesson 3 on the outer planets. So we're going to be looking at how they are similar, how the outer planets are similar, what these outer planets are made of. The outer planets are Jupiter, Saturn, Uranus, and Neptune. Just served us nachos. The figure below shows the sizes of the outer planets compared to each other and to Earth. So let's look at Earth right here. Okay, so wow, cool, much bigger, right? As you can see, their sizes are much greater than Earth's size. The outer planets are made of hydrogen and helium, mostly of hydrogen and helium. These elements are usually gases on Earth. Gases change to liquid at high pressure. This property of gases affects the outer planets. The outer planets are called gas giants. So gases change to liquid at high pressures. We're going to see that that's what happens. The outer planets have strong gravitational force due to their large masses. Because remember, mass and the distance between objects are the two elements that are responsible for gravitational force. The strong gravity creates tremendous atmospheric pressure that changes gases into liquid. Thus, the outer planets mainly have liquid interiors. In general, the outer planets have a thick gas and liquid layer covering a small solid core. All right. So, I forgot to have you guys do this, but let's go ahead and mark our colors for our sections in our reading essentials so that they can correspond to our outline notes, okay? All right, so gas giants, orange. Jupiter, green. Saturn, blue. Uranus, yellow. And Neptune, pink. So if we scroll, then we see our one vocab word for this lesson. All right, so pink, yellow, blue, green, orange, okay? So let's go to our outline notes, and we're going to see we have the exact same thing, okay? All right, so let's get them marked. Orange, green, blue, yellow, and pink. And then we are at lesson 4, so we can mark this. We are done at this point, okay? All right, so let's go ahead and fill out for gas giants. The outer planets are made of materials that are usually gases on Earth. Gravitational forces produced by their sizes of these planets change gases into liquids. And we're going to put off to the side here that the two gases are hydrogen, and the periodic table element symbol is capital H, and helium, capital H, lowercase e. So go ahead and get that written in, and we will switch back over to our reading essentials. Jupiter. Jupiter is the largest planet in the solar system. Its diameter is more than 11 times the diameter of Earth. Its mass is more than twice the mass of all the other planets combined. Jupiter takes almost 12 years to complete one orbit of the Sun. Yet, it rotates faster than any other planet. Its period of rotation is less than 12 hours. Jupiter and all the other planets have a ring system. Let's go ahead and change that because that's going to apply to all of them. You're going to see that they all have moons and they all have rings. And so its year, so once all the way around the sun, is 12 years, but its day is only 10 hours. That's pretty cool. Okay, Jupiter's atmosphere. The atmosphere on Jupiter is 90% hydrogen and 10% helium. The thickness of the atmosphere is about 1,000 kilometers. The atmosphere holds several layers of dense, colorful clouds. Jupiter's fast rotation stretches the clouds into swirling bands of color. The great red spot on the planet's surface is a storm of swirling gases. Jupiter's structure. Jupiter is about 80% hydrogen and 20% helium. Swirling gas covers a thick layer of liquid hydrogen over a solid core. The pressure at 1,000 kilometers below the outer edge of the cloud layer is great. There, the hydrogen gas turns into liquid. The core is probably rock and iron. The moons of Jupiter. Jupiter has at least 63 moons, more than any other planet. In 1610, Galileo Galilei discovered Jupiter's 4 largest moons. As a result, the 4 largest moons of Jupiter, Io, Europa, Ganymede, and Callisto, are known as the Galilean moons. All right, so there is our vocab. Collisions between Jupiter's moons and the meteorites likely created the particles that made up the planet's faint rings. All right, so let's go to our outline notes and do Jupiter. Okay. So Jupiter is the largest planet in the solar system. Although it takes 12 years to revolve around the sun, Jupiter rotates faster than any other planet, only 10 hours. Jupiter has a system of rings around it. Jupiter's atmosphere contains helium, but is mostly made up of hydrogen, 90%. Jupiter's rotation stretches its clouds into colorful clouds. The great red spot on Jupiter is a storm that has lasted more than 300 years. Jupiter's entire structure is made up of about 80% hydrogen and 20% helium and small amounts of other materials. Jupiter has a solid core that is surrounded by liquid hydrogen. That's due to, that gas turns into a liquid at those high pressures. The 4 largest moons of Jupiter are called Galilean moons. These are Io, Europa, Ganymede, and Callisto. All right, what I want you to mark here is this information right here. All right, that its revolution, we're going to do this for all of the planets. Its revolution, so its orbit around the sun, is 12 years. The rotation, its day and night, is 10 hours. And the AU is 5.20. Remember, AU is the distance between the sun and Earth. So that's 1. It's 150 million kilometers. So Jupiter is 5 times farther away from the sun than Earth. So make sure that you pause this if you need to get all of this written in, okay? All right, let's tackle Saturn. Change our color. The figure above shows the distance from the sun of the 5th and 6th planet. Saturn is the 6th planet from the sun. Like Jupiter, Saturn rotates rapidly and has bands of clouds. Saturn is about 90% hydrogen and about 10% helium. It is the least dense planet. And what that means is that when it talks about it being dense, that's like how much matter, how tightly packed things are. And this planet would actually float in water if there was something large enough that it could, like a body of water that would be large enough to accommodate Saturn, it would actually float because the density is less than water. and the density of water is 1. So they have determined that the density of Saturn is less than 1, so this planet would actually float. So this is a question on your study guide, so make sure that you get this written in, okay? Saturn is made up of mostly hydrogen and helium. Like Jupiter, Saturn's structure has an outer layer of gas, a thick layer of liquid hydrogen, and a solid core. Saturn's 7 bands of rings are the largest in the solar system. The main ring system is more than 70,000 kilometers wide. However, the ring system is likely less than 30 meters thick. Ice particles mainly make up the rings. The particle range in size from specks to chunks as large as houses. So it's very wide, but it's actually not very thick. So this would be 30 meter sticks. End to end is how thick it would be from top to bottom. Saturn has at least 60 moons. The 5 largest moons are Titan's, Rhea, Dione, Iopetus, and Tethys. Most of Saturn's moons are chunks of ice that are less than 10 kilometers in diameter. Titan, the largest moon, is the only moon in the solar system with a dense atmosphere. In 2005, Huygens space probe landed on Titan. All right, so let's go and get our outline notes done for Saturn. Okay, so like Jupiter, Saturn rotates rapidly and has clouds in bands. Saturn is mostly made of hydrogen, 90%, and helium, 10%. Saturn has the largest ring system in the solar system. Saturn has 7 bands of rings, each of which contain thousands of smaller rings. The rings are made mainly of ice particles. Most of Saturn's moons are small, but one of them, Titan, is larger than the planet Mercury. So we're going to get that filled in. Yep, because then we're at Uranus. We're going to write to the margin there that we have 60 moons for Saturn, 63 moons for Jupiter, 60 moons for Saturn. We're going to write that Saturn is the least dense planet. Density is less than water, so would float. We're also going to write this information here. That's going to help us visualize like how far out these planets are. So its period of revolution, so its year, so it's once all the way around the sun is 29.7 years. Its rotation on its axis, day and night, is 10.7 hours. And its AU is 9.6, so it's 9.6 times farther away from the sun than Earth is. So go ahead and pause this if you need to get this typed in. All right, so we are at Uranus. So let's come on down to Uranus. Change up this color. Uranus is the 7th planet from the sun. It has narrow, dark rings. The diameter of Uranus is about 4 times that of Earth. The Voyager 2 space probe explored the planet when it flew by Uranus in 1986. The deep atmosphere of Uranus is mostly hydrogen and helium. There is also a small amount of methane. We're going to do that blue because methane is what makes it look blue. It's the methane. Beneath the atmosphere is a thick, slushy layer of water and ammonia and other materials. Uranus might have a solid rocky core. So this is very unique for the planet of Uranus, this little section. The sideways tilt of Uranus' axis of rotation is different from those of the other planet. It's tilted so that the planet moves around like a rolling ball. Uranus has at least 27 moons. The two largest moons, Titania and Oberon, are much smaller than Earth's moon. Titania has an icy, cracked surface. At one time, an ocean might have covered Titania's surface. Okay, so as far as this rolling on its side, it is thought that a collision with an Earth-sized object is what tipped it on its side. So bang, hits it on its side. So instead of being up and down like so, perhaps then it's more rolling like that, rolling on its side like a ball. All right, so let's fill out this next section on Uranus. So Uranus's atmosphere contains mostly hydrogen and helium with small amounts of methane. That's what makes it look blue. Beneath Uranus' atmosphere is a slushy layer of water, ammonia, and other materials. Uranus might have a rocky core. A little redundant there, sorry. The rotation axis of Uranus is tilted more than any other planet, sideways like a rolling ball. So its thought was that caused by a collision with an Earth-sized object. Did it bang into it and then tilt it on its side? Uranus has at least 27 moons and a small ring system. So we're going to write 27 moons in our margin. And then here we have the information that we are tracking for each of these planets. The revolution is 84.3 years. Okay, so let's look at the planet right prior to 29.7. So what, almost 3 times farther out then. Rotation 17.4, so still really fast. And the AU is 19.2. So it's 19.2 times farther away from the sun than Earth is. So go ahead and get all of that written in for Uranus. Pause this if you need to. And then we will wrap up with Neptune. All right, let's change our color. Like Uranus, Neptune has an atmosphere mostly of hydrogen and helium and a little methane. Like Uranus, Neptune's interior is frozen water and ammonia with a core of rock and iron. Neptune has at least 13 moons and a faint ring system. Triton is Neptune's largest moon. Triton is made of rock with an icy outer layer. Triton's surface is frozen nitrogen. Geysers on the surface erupt nitrogen gas. There we are at our end. So we are ready to fill in our outline notes for Neptune. So the atmosphere and interior of Neptune are similar to Uranus. So they have that hydrogen, helium, and methane. So that's what makes it look blue. So these last 2 planets, Uranus and Neptune, have methane also in their atmosphere. Neptune has at least 13 moons and a faint ring system. So let's take a look at all of this information. So its revolution, its year, its one time around the sun is 165.2 years. So practically doubled that of the nearest planet, Uranus. Its rotation is 16.1 hours and the AU is 30.1. So it's 30 times greater, 30 times farther away from the sun than Earth is. All right, I want you to write this in at the bottom. The outer planets, they all have moons. All of them do. They all have a ring system. They all have hydrogen and helium in their atmosphere. And they all rotate on their axis faster than Earth does. So their day is shorter than our Earth day. And we can see that when we look at the rotation on these planets. Okay? So I'm going to give you a second. You can pause this. I do have one more thing I want us to do on these outline notes. So get this written in. This is going to be important for your study guide. Okay, so let's go back up to the inner planets. And we are going to add the rotation and revolution in the AU for all of those planets. Okay, so revolution is 88 days for Mercury. That makes sense because it is so close to the sun. Rotation is 59 days, and the AU is 0.39. Now it's going to be less than 1. Of course it's going to be less than 1 because it's prior to Earth. So the first two planets, Mercury and Venus, they're before Earth. Earth has an AU of 1. So if these planets are lying before Earth, they're going to have an AU that's less than 1. All right, so let's take a look at Venus. Its period of revolution is 225 days. That's how long it takes to make one all the way around. But then look at its rotation, 244 days. So its day is longer than its year. It rotates so slowly that its day is longer than its year. And the AU is 0.72. So it's less than 1 because this planet shows up before Earth. All right, so then this is information that we know. The revolution is 365 days. Rotation is 24 hours, and AU is 1. So 1 AU equals 150 million kilometers. Okay. So let's make sure that we have all of this information about Mercury and Venus, and then Earth, and then here is Mars. So the revolution, how long it takes one all the way around the sun, is 1.88 years. Rotation is 24.6 hours, so just about the same day and night time as Earth has, and the AU is 1.52. Now that makes sense because it's further out. It's the next planet out from Earth, so its revolution is going to be longer because it's having to go farther. Its AU is going to be larger because Earth is 1. Anything after 1, anything after Earth is going to have an AU greater than 1. Anything prior to Earth is going to have an AU less than 1. So make sure you have all of this information written in about revolution, rotation, and AU for the inner planets as well, okay? Stop this video, rewind this video at any point to make sure you have all of the information, okay? All right, thanks.